Yes.
So basically, if we start with one paper, it is from 22 May, June, paper 4 variant 1, because now we have to attempt paper 4 for the theory, and we also need to discuss paper 5 any day, because that is related to like ATP type paper, just like you did in IGCSE. So for the time being, if we start with the theory paper, so the very first question you can see that is from your first chapter, which is related to the gravity. So you have to state Newton's law of gravitation. Now just take all the notes in front of you, if you have in soft copy or in hard copy. So that will help you to, because when you try to solve the paper, so that will automatically revise your concepts, right? The old concept that we already discussed. So basically, state Newton's law of gravitation. So state Newton's law of gravitation is very simple. You know that the force of attraction, or the formula for the law of gravitation, is F is equals to G m1 m2 over r square, right? Or we write capital M or small m in the place of m1 or m2. So this is the law. And with the help of this law, you can easily write the statement that the gravitational force, I'm writing in the short, right? Just to save the time, because you already have that notes of Newton's law of gravitation. So gravitational force is directly proportional to the product of their masses. And it is inversely proportional to the square of the distance between them, right? That is r square. Okay. Directly to the product of masses, inversely to the square of the distance, right? Any confusion?
No.
Okay. And the next part is, in the next part, they are asking use Newton's law of gravitation to show. Basically, this part is related to the derivation part, because you know that they ask about the derivative part also. So we have to use Newton's law of gravitation to show that the gravitational field strength at distance r away from a point mass is given by this formula. So we have to start from law of gravitation. So this is the law of gravitation, right? And we know that the value of gravitational field strength is F over m. Okay. This is the definition of gravitational field strength, force acting per unit mass on a body. Okay. And if you just substitute the value of F from equation 1 in equation number 2, so your equation 1 will be equals to, sorry, your equation 2, because we have to substitute the value of F from equation 1 in equation number 2. So it will be equals to, this is the value of F divided by M. And this small m will cancel out, right? And you will get your final answer. Very simple 2-mark question. Okay. So they will ask the derivation like this. You already solve in the practice questions, if you remember. We also drive the same situation in the notes also, or in one topical sheet also, right? And let's suppose if we consider the next part. So in the next part, there are some values given. The earth has a mass of, this is the mass of earth, and this is the radius of earth. Same goes for the moon. Same goes, okay. Now they are saying that the earth and the moon can both consider as a point mass at the centers. The center are at the distance. So basically the distance between the moon and the earth is taken as 3.84 exponent 8 meters, right? Clear?
Yes.
And now what we have to find, they are asking that show that the gravitational field strength at the surface of the moon due to the mass of the moon is 1.6 Newton per kg. Now again they are asking about the value of G, that we have to calculate the value of G, gravitational field strength, that we already derived in first equation or in the first part. So basically in the question, you know that all parts are interconnected. So now we have to use the same formula, Gm over R square. So the value of capital G is constant. And in your paper, you will get in the data sheet, this is the value of capital G, right? 6.67 exponent minus 11. So you don't need to remember. You can take the value from your data sheet. So we just need to substitute the values. 6.67 exponent minus 11 multiplied by mass. So which mass we have to place over here? Mass of moon or mass of earth? We have to take the mass of moon, because in question they are asking about the moon divided by the distance, square of the distance. And in distance, what will be the value of the distance? You have to take the distance or the radius of the moon, because we are only talking about the moon. We are not talking about the earth right now. So if you just calculate from the calculator, so you will get the same answer of 1.62 Newton per kg. Okay. Any confusion? So this is the second part of the question, very easy. And in the next part, they are asking, explain why there is a point X on the line between the center of the Earth and the Moon, where the resultant gravitational field due to Earth and Moon is zero. So let's suppose they are asking like this, if we consider the Earth surface, if we are having Earth surface over here, and if we are having a moon over here, and they are asking there is a point X lies between the center of Earth and Moon. So let's suppose if we consider in the center, this is point X, right? And at this point, they are asking the resultant gravitational field strength is equals to zero. It means there will be no gravitational force acting at this point. Okay. So you know that the concept of resultant force, when two forces are equal and opposite, so their resultant force will be equals to zero. Okay. And if we are taking the center point, so from the center point, the gravitational force of the moon acts towards the moon, and the gravitational force of the earth attracts towards the earth. So basically both forces are in opposite direction. So it means that we can say the field due to the earth and field due to the moon have equal magnitude. So that's why your final resultant force or the final resultant gravitational field strength will be zero at this center point X. Okay, clear? Any confusion? So the gravitational field due to the earth and the moon have equal magnitude at point X. So it means that when forces are equal and opposite, you can see both forces having their own different direction and both are equal in magnitude. So it means that the resultant field strength at X will be equals to zero, right?
Yes.
And in the final part of this question, you can see question is very easy and it is of 10 mark. The very first question for 10 mark, very simple. So calculate the distance X of point X. So point X is the center point. This is different. And this small x distance is different from the center of the moon. So we have to calculate the distance x from the center point. So basically what they are asking according to the question, one more thing that is given in your question, if you just take the reference from their centers, so these are their centers and the distance between their center is given. It is given in the question 3.84 exponent 8. So this is the distance between their centers, right? Like from the center of the earth to the center of the moon. It is mentioned in the question also, right? And they are asking the distance x. So they are talking about the moon. So basically we have to find this distance, the small x, from this x point to the moon. Okay. So what we need to do, we know that the gravitation of moon and the gravitational field of earth both are equal, okay, at point x, right?
Yes.
And if we just write the formula for both the gravitational terms, so basically there are two m, that's why I write moon and earth, so you will not get confused in that because both are having different meanings. So we can say that the value of r is different because the surface of the or the radius of the earth is greater than the moon, right? So the field of the earth is greater than the moon, right? It will be more wider as compared to the distance of the moon from point x and the distance of the earth from point x. You can see that the distance I marked over here is different. You can see that purple line is greater than the blue one. It means that the distance from x point to the earth is greater because earth is greater in radius as compared to the moon. So it will apply more force till more distance, right? Okay.
Yes.
So basically we are not going to cancel out the value of r, we only cancel out the value of g. Okay, because we know that both g values are constant, so they can easily cancel out each other, but we are not able to cancel out the value of distance, because we know the reason that both are at different distances, not at the equal distance. Okay.
Okay.
And finally, if we just substitute the values of the distance, so we will substitute the values of the distance like this, that the mass of moon we already know. So from the question it is already given, we can just substitute the value. What about the distance? So basically distance will be x square, because it is given in the question, you have to find out the value of x. So x is unknown. And if we talk about the earth, so mass of earth is also given. And if we take the distance, because the total distance is 3.84 into 10 ki power 8 meter between the center of the earth and center of the moon. Okay. And if you just draw a reference line, so basically this distance x, we can easily find out this distance x from subtracting the value of 3.84, right? Because if we subtract x from the given length, so you will able to find out the distance, right? Clear?
Yes.
So we can write over here that the earth distance will be the total distance minus the distance of point x and the moon. Okay.
Mm.
So this is the equation. Now we just need to substitute the values, and the values of the moon is, the mass of moon is given, which is 7.35 exponent 22. X square is unknown. Mass of earth is also given in the question. Now you know that we have to apply the under root to solve this x square, right? So we have to apply under root on both sides. So you can just simplify your equation. Let's suppose if we just apply under root on both sides. So this will cancel out this one. This will cancel out this one, but we have to apply under root on the upper values. So I'm just writing in simple form. Right? Any confusion?
No.
So now what you need to do, you just need to cross multiply, find the under root and calculate the final result. Okay. I hope you can easily find out that there will be no confusion in that. Okay.
Yes.
So try to solve this question after the class, and you may check the answer from marking scheme also. But you know that the process is very simple, because it is a lengthy process and there is only mathematical calculation. You can just put all the values in calculator and that will be easy for you to calculate it, because now we only have mathematical concept, right?
Yes.
Okay. So this is the first question. Okay, second is related to the electric field. Okay, we just skip this part for the time being because we didn't discuss this chapter. Okay, question number three is related to the gases. So a fixed mass of an ideal gas is initially at temperature of 17 degrees Celsius. So basically in first part of the question, they are asking that if the initial temperature is given and the gas has a volume of 0.24 meter cube, this is the volume, this is the initial temperature, this is initial pressure, right? So first of all, we have to define what is meant by an ideal gas. So do you remember that definition of ideal gas?
Um, Ideal gas, get just like a helium.
Okay, basically when we are talking about the ideal gas, so with the concept of ideal gas, we can say that the gas which actually obeys gas laws, right? So when we are able to apply
Yes.
the gas laws on the given gas, so it means that is the situation or that is the example of ideal gas, right? A gas that obeys gas laws are known as an ideal gas because we use the equation PV is equals to nRT. So that's why we use this equation to find out the unknown value given in the equation, right? So basically, this is the first answer of your first question. And in the second part, they are asking about the calculations. And what are the calculations? You have to calculate the amount of gas. And if you remember the formula that we already write in the definition, PV is equals to nRT. So basically, we have to calculate the small n. So we use small n from the equation. N will be equals to, and we know all values are given. P, V, T is given in the question and R is a constant value that is given in your data table also. That is 8.31. So we need to substitute the value. Pressure is 1.2 exponent 5 multiply volume is 0.24 divided by R is 8.31 multiply by the temperature. And temperature is given in Celsius. And if you have to convert this temperature into Kelvin, so you know that you have to add 273. So that will be equals to 290 Kelvin, right? Because for ideal gas, we have to convert temperature from Celsius to the Kelvin, right? And you will get your answer 11.59, 11.95 but we have to convert into two significant figures. We have to round it off. So it will be equals to 12 moles, right?
Yes.
Okay. Now in the next part, the gas undergoes three successive changes as shown in figure 3.1. So basically there are 3 points A, B, C. So first we move from point A to point B. You can see the direction. A is moving towards B, then B is moving towards C, and then again C is moving towards A. So basically there are three different changes in the question. Okay, clear?
Yes.
So now let's see the question. And if you remember, yesterday we discussed the concept of PV diagram, pressure volume diagram. So in this question, we
Yes.
have used that PV concept. Let's see what they are asking. The initial state is represented by point A. The gas is cooled at constant pressure to point B. You can see that from A to B, we are having constant pressure, right? Because y-axis is not moving till A to B. So we are having constant pressure. So at constant pressure, we move from point A to B, and by the removal of, there is a value of energy given, 48 kilojoules, right? And then gas is heated at constant volume to point C. So you can see from the diagram that at constant value, your graph will move in upward direction. So this process take place at constant volume, right? And finally, the gas expand at constant temperature back to its original pressure and volume at point A. During this expansion, the gas does 31.6 joules work. So this process involves expansion, because when it expands, the volume will increase. Any confusion in the question till now?
No.
Okay. Now let's see the question. We are having two values of energy. One is 48, second one is 31.6 kilojoules. Now they are asking, show that the magnitude of the work done during the change AB is 19.2 kilojoules. So basically, first of all, you need to calculate the work done, right? So for the work done, if you remember yesterday we solved the work done. Work done is equals to pressure into change in volume, right? The final simple statement. Okay.
Yes.
So we have to use that concept over here. So that will be equals to, so pressure into change in volume. So the value of pressure is given. Okay. So for the formula, we first need to take the value of pressure from the question. Value of the pressure is 1.2 exponent 5. Okay. And what will be the volume change? They are asking between to B. From A to B, this is the volume at point A. This is the volume at point B. Okay. So we need to subtract these volume to find out the final change in volume. Okay. Clear?
Yes.
So 0.24 minus 0.08. So your final answer will be equals to 19200. And if we just convert into the decimal form, so we need know that it will be equals to 19.2 and 3 decimal place shifted. So kilojoules. Okay.
Okay.
So this is the value of the work done. And if we take the next part of this question, so in next part you have to complete the table. So basically from A to B, we already calculated the work done, right? Your work done is actually equals to 19.2. Okay. And it will
Okay.
be positive or negative because we are moving a greater volume to the less volume. So your volume is decreasing. And if you remember, we discussed yesterday that when gas expand, W will be negative, and when gas compress, W will be positive. So we have to put positive sign, right? Because gas is compressed over here because volume decreases. So it will be positive. Okay.
Okay.
And in the third box of AB, we have to write the internal energy. We know the first law of thermodynamic. First law of thermodynamic is, so we have to write the final answer of delta U. Okay. So we have to use the value of delta U, and we can easily find out from the equation with the help of the values given in the table. So if you calculate the value, what will be your final answer? We know that thermal energy is in negative. So minus 48 minus 19. Basically, we have, sorry, it will be, yes, work done will be subtract on the other side. So we have to subtract the values. So you will get the remaining part as internal energy. So it will be, right? Any confusion?
No.
And in part B till C. So basically, from part B to C, we know that volume is constant. So when volume is constant, what will be the value of W? If volume is not changing, so is there any quantity of work done or not?
No.
Zero work done, right? Because volume is not changing, piston is not moving, so no work done. So your work done will be equals to zero. So the first column equals to zero. And for the next two boxes, we have to identify the rest of the values. And one more thing, if we talk about C to A, and if we talk about C to A, so basically from C to A, we are moving in downward direction and we are doing work. Plus your internal energy is also, we have to check out the internal energy. So basically your all energy is going to be consumed in the work done. Okay. Because work done is given 31.6 in this question. And there is also a thermal energy over there. So basically when you are doing work, so there will be no internal energy because your pressure volume both are changing from C to A. In A to B, you are working at constant pressure, right? So there is a value of internal
Yes.
energy because your pressure is constant over there. So your internal energy will increase. And when you are working with variable pressure, variable volume, so there will be no increase in internal energy, right? And now we have to fill the remaining three boxes. And in the remaining three boxes, we have to know about the thermal energy supplied to the gas between B to C. So basically, in A to B, we stored energy is equals to 28.8. So when we are working from B to C, so we are working at constant volume. So constant volume means you are getting the same thermal energy, 28.8, right?
Yes.
So you are getting same energy over here. And since you are doing no work done, zero work done, so 28.8 minus 0 will again equals to 28.8, right?
Yes.
And finally, the thermal energy supplied to the gas between C to A. So basically from C to A, how much thermal energy we consume? Basically, we are doing work of 31.6, right? And we know your internal energy is zero. So according to the law of thermodynamics, this is the law of thermodynamics, right? And we know from part C to A, we can easily identify that there is a value of work done, right? Internal energy is zero. So what will be your thermal energy supplied to the gas? What will be the value of that? You can easily identify now.
31.6.
31.6, because you know that there is no change in internal energy. So definitely you are getting same value with positive, right? Because you reach the same point from where you started, like point A. So again, you will get the energy in form of positive sign. Okay. And then this will process repeat again and again in the same manner, right?
Yes.
So this is your from thermodynamic, and ideal gases like 10 marks for that, 11 marks for this. So 21 mark question, two chapters, right?
Yes.